people, and welcome. In today's video, we are talking about how to graph a cube root function. Now, as always, if I make a mistake, I am human. Please let me know what the mistake is so that way I may learn from it. All right, beautiful people, I went ahead and I kind of wrote out a few different notes that I would like to explain to you. Please make sure to write these down so that way you have them in your notes and can use them. So a cube root function has a 3 in here. What that means is we want three numbers that are the same that multiply to give us this x on the inside. So we have our reference points like we did when we have a cubic function. So we have our reference points, and you're going to notice that the reference points are exactly the same. -1, -1, 0, 0, 1, 1. Now, how did I get those reference numbers? Here's my input of -1. I put in my input in for x, and the cube root of -1 is -1. The cube root of 0 is 0, and the cube root of 1 is 1. So here is my reference points. You still have your two options. You have an increasing, decreasing function. So if it is a decreasing, make sure that your leading term is negative. And so notice that you don't have a cubic function. You have a cube root. So it's not going to give you a John Travolta like we usually know. It's going to give you a little sideways John Travolta, as in increasing is going to go increasing left to right. The curve is not vertical. Okay, the curve is horizontal. Think inverses. Cube root is the inverse of a cubic function. So if we have originally a John Travolta that is vertical, the cube root is going to give you a John Travolta that is horizontal. So this is going to be your increasing function, your increasing curve, and this is going to be your decreasing curve. Again, you need 3 points to graph these. Here are your two options when graphing. So you have your f of x is equal to a times your cube root of x minus h plus k, and you have your f of x is equal to cube root of b times x minus h plus k. Your point of symmetry, your middle point is still h comma k. So whatever you knew about graphing cubic functions is exactly the same. The reason these are splitting up is because a lot of times what you're going to find is you can absorb b into your a. So I usually go with this top equation. Sometimes your book or CUDA will have you write it or graph it from this form. It works exactly the same way as we did graphing cubic functions. All right, so here are our points on how to graph, or here are our steps on how to graph cube root functions. So step number 1, you're going to set the inside of the cube root equal to 1, 0, and -1, just like we did originally with our bubble. Your bubble is going to be your cube root. You're going to set the inside of your cube root equal to 1. You're going to set the inside of your cube root equal to 0. And for the third one, you're going to set it equal to -1. You're going to solve for your new x's. Once you have your new x's, that is your parent function transformed into your new x's. Take those new x's and substitute into your original equation to be given your new y's. Now that you have your new x's and y's, you may graph. So let's go ahead and do some examples. All right, here's our first one. We're going to do one of each. So step number 1 is set the inside of the cube root equal to 1, 0, and -1. You're going to then solve for your new x's. So your new x's is 4. I have a new x of 3, and I have a new x of 2. You're going to then take your original equation, which is f of x is equal to 2 cube root of x minus 3 plus 5. It's a little bit on the longer side. Let's shorten that up. And you're going to then substitute in for your x your value. So you're going to substitute 4 in. So this is 2 times the cube root of 4 minus 3, which is 1. Cube root of 1 is 1. 2 times 1 is 2 plus 5 is 7. So your input was 4, your output was 7. Give me a second, you guys. Alrighty, let's go ahead and move on to the second one. So now I'm going to plug in 3 in here, and I'm kind of going to do it in my head. 3 minus 3 is 0, right? 3 minus 3 is 0. Cube root of 0 is 0. 2 times 0 is 0, so my input was 3, my output was 5. And again, just because I'm short for space, I'm going to go ahead and do this one in my head. 2 minus 3, I'm taking my input of 2. 2 minus 3 is -1. Cube root of -1 is -1. -1 times 2 is -2. -2 plus 5 is 3. So now we have 4, 3, 2. So I have 4 and 7. I have 3 and 5. And I have 2 and 3. Notice it's giving us that potential line. However, you need to know in your head that this is a cube root. Cube root means John Travolta, that is horizontal. So you're going to have two options. You're going to have an option like that, or you're going to have an option the other way. Increasing or decreasing function. Oh, you can't see that. Let me zoom in just for a second. This is what I do immediately, like when I see these, because in my head, I don't want to accidentally draw a vertical John Travolta. I know that it has to be a horizontal John Travolta. So because this is an increasing function, I'm going to go up and to the right, and I'm going to go down and to the left. It has to be a horizontal John Travolta. It cannot be a vertical John Travolta. And you've cracked it. So let's do one example where the equation is in the other form, where it has a B and not an A. Steps are exactly the same, you guys. So you take your inside bubble of 1/2 times 10 minus, just kidding, 1/2 times x minus 10. You're going to set that equal to 1. You're going to set that equal to 0. And you're going to set that equal to -1. It is your choice if you want to distribute that 1/2. This is 1/2 times a bubble. So I'm going to undo that 1/2 times by multiplying by 2 on both sides. Or you can distribute, it still would give you the same output. So I have 10 minus, I keep saying 10 minus, it's x minus 10 is equal to 2. I have an x minus 10 is equal to 0. And I have an x minus 10 is equal to -2. I'm going to add 10 to both sides and see what my new x's are. Oops, that should be a 1. So what do I have here? I have a 12, I have a 10, and I have a 8. Then I'm going to take each of those. Oh, you guys can't see that. I apologize. I'm going to take each of those and plug it into my equation. I'm going to take the cube root of 1/2 times x minus 10 plus 4 is on the outside. So in here, I'm going to do 12 first. Then I'm going to do 10. Then I'm going to do 8. And I'm going to solve for my new y's. So I have a cube root of 1/2 of, what is this, 2 plus 4. This is 0, cube root of 0 plus 4. This is cube root of 1/2 times a -2. So this means I have here, what do I have here? I have cube root of 1, which is 1 plus 4. So I'm going to have an output of 5. This one here is a cube root of 0, which I'm going to have an output of 4. This one here is -1, so I have -1 plus 4, which my output is 3. Alrighty, so then we're going to just plot those points. So I have, I'm out of space. There's 12. Let's see, I have 9. I go up to 9. It's okay. We can extend it out. So this is 9, 10, 11, 12. 12 and 5 is going to be here-ish. 10 and 4 is going to be here-ish. And 8 and 3 is going to be here-ish. Again, we know this is horizontal. We're looking at our leading coefficient. Leading coefficient is 1. It is positive. So then we're doing horizontal John Travolta. Give me a second here. All right, now let's see if we can go ahead and sketch this out. Now, as always, make sure to look at your leading coefficient and make sure you are aware that this is a cube root function, meaning it is the inverse of a cubic, meaning that we will have the horizontal version of John Travolta. So horizontal version of John Travolta will give me either one of these, oh, you can't see, or will give me one of these. Oh, not that one, this way. So arrows will be pointing either to the left or to the right. Arrows will not be pointing up or down. So since we are an increasing function, our leading coefficient is positive. We're going to look something like this. So from the middle point, I'm going to go down and to the left. And from the middle point, I'm going to go up and to the right. That looks a little bit squished here. The function that we graphed is a little bit bigger than what we are given on our coordinate system, but that's okay. Should look something like that. As always, beautiful people, thank you so much for watching my video. Graphing cubic root, graphing cube root, graphing all of them. The method is exactly the same. Take whatever you have underneath your root, set it equal to your reference points, in this case 1, 0, and -1. Find out your new x values, take your new x values, plug it into your equation, and solve for your y. As always, thank you so much for watching, and I will see you in my next video. Bye!